Okay, guys, we have a MacBook Pro 15 inches. It says question Mac. That's the description. It says question Mac. I'm not sure if you guys can see that. Yeah, it says question Mac. Um, so this is I suppose this has been tested. So the first thing we want to do is we power the machine on, then hold the Alt key and see if we get anything. Hmm. Okay, this seemed to work. I'm not sure why. Uh, I'm not sure what they meant by question mark. Hmm. This works just fine. Okay, let me try something and shut it down. Fine, on without having to hold the option key. Let's see, and it works just fine. Okay, I'm not sure. Yeah, I'm not sure why this came for question mark. We'll just move on to another video, another repair, because apparently this I don't see anything wrong with this as far as the description on the machine. The machine clearly has an operating system installed. I thought it was a drive not being detected type of issue, but I'm not sure why this was written question mark. It clearly has no question mark. Okay, let's get another device. Okay, this is going to be our last repair for tonight. So this is no power. It's an A2141. It's a 16 inches A2141. So you guys can see that. Yeah. So this is a no power. Uh, hmm. The first thing we want to do here, before we open up the device, is we want to see if we can put the device into DFU mode. So because it's an Intel device, to put an Intel machine in DFU mode, we utilize the second port. So um, on your left hand side, so the second port on your left hand side, this one here, the second port on your left hand side is what you utilize because it's Intel. If this was an M1, you will use the first port. So and then on the host device, which is the device that you will be using, the one that will have Apple Configurator 2, it doesn't matter which port you connect the device to, but the device itself that needs to go into DFU mode. If it's an Intel, it has to be on the second port on your left hand side. If it's an M1, it should be on the first port on your left hand side. Now I'm just going to connect that. Okay, so the next thing I want you to do is, so in order for me to put the machine in DFU mode, I will be having to hold down four combination of, there will be four keys combination. It's going to be the power button, the control, the alt, the control option, and the shift key. So it's going to be the left control, the left alt key, the right shift key, and then the power button. So let's do that. Now, when you hold this four keys for about 10 seconds, basically. So so what we do now is we hold down, uh, just move this to the side so you guys can see it. So it's going to be the control, the alt or the option, the shift, and the power button. So Now I count 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, 10, 10, 10, 10. Now, sometimes you may have to try multiple times before you're able to get into a DFU mode. So, and obviously the device will go into DFU mode if all conditions are met for the device to go into a DFU mode. There are also certain power rails that need to be present before you can get the device to go into DFU mode. So I'm going to try that again. So I'm going to hold down my power button, my right shift key, my left control, and my left option key. So I'm just going to try that again. 1, 1, 2, 2, 3, 3, 4, 4, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, 10, 10, 10, 10. Nothing. So we'll try again for another time. 1, 1, 2, 2, 3, 3, 4, 4, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10. Nothing. Try for the last time and then we can open up the device. 1, 1, 2, 2, 3, 3, 4, 4, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10. Okay, the device does not go into DFU mode. So I will assume that the conditions necessary for the device to go into DFU mode are not met. And then I'm also hoping that we do not have a short resulting from the NAND, which is the SSD circuitry. So the next thing we want to do is take out the logic board. So it's always safe before you connect power to your device to be sure of what state the device is in. You don't want to run more power to a device that is maybe having a short, and then it may be that a circuitry that is designed or that's supposed to say, for example, get 3 volt, but because the buck converter it's basically dead, and now which means whatever voltage that comes through the buck converter will just pass directly to the circuitry that is designed to receive less than to receive about say 2 volt, for example, and then it sends out all of what it receives. So it's always safe to get a better idea of what state your board is in before you run power or before you connect power to your device. So the back cover is out. I'm just going to show you guys how it looks inside. So this is what it looks like. So I don't see any sign of liquid. Okay. So the next thing you want to do is disconnect the battery. So have the battery disconnected. Now for this design, the battery connections has two. Um, so there are two connections to your battery. You have the main power line, and then you have the cable as well. So I'm talking about. So you have this, and then you have the main battery power. Then this is going to be your battery data cable. Now this design was implemented this was a design that was implemented from 2016, 13 inches and 15 inches non-touch bars and touch bars alike. So this was, although a similar design like this was first implemented in 2015 with the 12 inches, but with the 12 inches it had no data cable. It only had the main power cable that will basically be will be made in place with a with a screw, just like this. You see, there is a screw that is basically allowing the board and the logic board, the battery and the logic, the battery mini board and the logic board to establish connection. So this was the first. This was first done in 2015 with the 12 inches, and then eventually in 2016, and then they basically started to roll out the design of having to have a main battery line and then a data line. So with this cable disconnected, my battery is basically disconnected so disengaged from the board. Now, this is true if this is an Apple original battery. Sometimes when you have Chinese knockoff batteries, even with this cable disconnected, the battery will still be active. So just to be safe, you can as well remove the screw that is connecting the main battery power line to the logic board. So that's what you're going to do. Now, you see, so another thing I want to say is, so when you are using your screwdriver anything closer to your battery cells, always make sure you kind of protect your screwdriver like this, because you don't want your screwdriver to slip into having to punch a hole in any of the battery cell, which will render your battery damaged. So you try to kind of protect your screwdriver like this. This can also be applied in other sections of the board, especially when you are walking around, say, um, a delicate component on your logic board. So you don't want to damage your screwdriver by, you don't want to damage you don't want to create any type of damage with your screwdriver by allowing it to slip. So with that out, now the battery screw is out of the board. The next thing we want to do is we want to check if we have a short on our board. So basically that is like the first thing I like to do. So I want to see if I have a short on my board before I connect power to it. So so this board, this is an 820-01700 2019 16 inches. Let's open up the board view. So yeah, it's going to be 820.01 So we want to check for short on our PP bus at the two fuses here. There's F7000 and F7001. There's two fuses here. So our multimeter is in continuity mode. In continuity mode, it doesn't matter what probe goes to where. Either, I mean, it doesn't matter if black probe goes to ground and then the red probe goes to whatever. It doesn't matter. In continuity mode, you can place your probes however you want to. So now let's see what we have on our PP bus. Okay, good thing. PP bus seem to be fine. I'm just going to check that again. Okay, so as you can see, we do not have a short on our PP bus. Let's see if we have a short in any other section of the board. Okay, we have a short, and I am just hoping that that short is not connected to the SSD rail. Um, so I'm getting bips at this cap here, which is C9587, and that cap it's connected to the NAND. That also explains why we were unable to put into DFU mode, because you need the NAND to be functional in order for you to be able to put into DFU mode. So we are getting a short at PP2V5, which is a 2.5 volt power rail to your NAND. Let's just confirm that again. Okay, that is a short. So what we want to do now is we want to take out our board, and we just hope that that short is not present in one of the NANDs. We are hoping that the short is going to be contained in a cap, because that way the client can still retain their data. If the short is contained in one of the NAND, the repair would mean that we'll have to replace the NAND, And in that will also mean that the client will lose their files. So we're hoping that that's not going to be the case. We're hoping that the short will be contained in one of the cap and not the actual NAND. To take out the screw, to take out the board, we will be, to take out the back screws, we need a P5, which is a pentalobe screwdriver. And to take out the board, we need a T5 and a T4, and also a T6, which is a T6 or T8 screwdriver. And that there are basically only two screwdrivers which are holding the heatsink, the two ends of the heatsink to the board and the frame itself. So we will need a T5, a T4, and a T6 or T8. The 16 inches they are very you commonly have issues with the 16 inches of having um, um, faulty NAND, and that not only make the repair expensive, more expensive than it should be, but it also causes the client to lose their data, because the NAND, which is the version of a soldered on SSD, when the drive is faulty, then you won't have access to the data. So, and for this machine, when the drive is faulty, especially when the drive is shorted, you will have, it will prevent the machine from starting, just like as we see now. So, you see, up until now, I am still yet to connect my charger. You see, which is very important. Like I said, you only connect power to your machine when you are sure of what state the machine is. Up until now, I still didn't connect power to my machine because I am having a short, and in this state, it is not ideal to connect power to the board. And this is also why I do not like to connect power to my board until I am sure of what state my machine is in. It is not ideal to use a tool to disconnect your cables unless you are very much, you can see up close exactly what you are doing with the tweezer, because you do not want to ruin anything. So you have, it's always ideal to use your fingers, but in a situation where you probably your fingers are cut short, your fingernails are cut short, then what you want to do is you want to make sure that you are you are 100% in control of your tweezer. You don't want to just, you know, you don't want to break things using your tweezer without having to be aware of it. Okay, now the logic board is out. Let's put our shell aside. So this is the other side of the board, and okay. So you see that section of the board, that, see that cap there doesn't look good, and we are hoping that see, so we are hoping that our cover will be contained in that cap. That would be really good, because if that's the case, it means our land will still be safe. So this is the entire board. See, there's accumulation of dust here, which has also formed some kind of marks, and also has created a damage to the cap that we can clearly see there, that cap there. And that cap, this cap here, let's see what that cap is. Uh, okay, that doesn't look good because that cap, which is this one, that cap is this here. That's a PP bus. That cap is sitting on the PP bus line, and we did confirm that we do not have a short on our PP bus. Let's just confirm that again. Yes, we don't have a short on our PP bus. So let us see what is going on in that section of the board. Okay, so this cap C9586, C9586 also look a bit which is this one here. So that's C9586. That is C9586. That looks a little bit suspicious. So let's see with that out of the board. Let's see what happens. Let's measure the individual cap. It's now out of the board. Let's see. Okay, that's the cap is just fine. It did look funny, but the cap is not faulty. Um, there is also, let's see, there is also this, but that it's a PP bus also. Um, so just by, you see, that is a cap. Also, this looks funny, but let's see what that is. That is also PP bus. That is also PP bus. Uh, okay. Hmm. We are really hoping that we do not have issues with either of the NAND. Okay, so first let's remove U9850 because U9850, that section also looked a little bit funny. Um, I'm not sure if you guys can see that. 9850 also looked funny. So what we wanted, so this is U9850, this. So that is a regulator, that's a 2.5 volt regulator to the SSD. So we are now this U9850 takes PP bus voltage and then it splits it down and then you get output of 2.5 volt. Now, I'm just going to show you guys. Let's open the schematic of um, hmm, 820, 00, no, 01700. There you go. So it's U9850. Okay, here you go. That's U9850. Now, U9850 has two outputs, and both, as we see, they are critical. Two outputs, let's see. So, I mean, you have 2.5 volt, not typically two outputs, just two inductors on the same line. So you have this, and then it gives you 2.5 volt, and then see that 2.5 volt, and then you also have, let's see what else you have. What else you have on that line? So pretty much is V in, V in, V in, and EN, and then yeah, and then pretty much. So that is what is expected of it, 2.5 volt. Now, the V in, it's going to be PP bus. As we see here, V in is going to be PP bus. So should U9850 fail, it will send the same PP bus voltage as output to a 2.5 volt line to a 2.5 volt line instead. So what we want to do is we want to remove U9850, and then we hope that U9850 it will be the only issue and not the NAND. And then also, while you are working in this section of the board, while you're working in this section of the board, you want to make sure your hot air is contained in this section without having to. You maybe make sure your hot air stay far. These are the NAND chip. You make sure your hot air is far away from the NAND chip. Yeah, so because you don't want to. Yeah, you don't want to basically melt the balls on your NAND chip. So let's take out our U9850 and see if that will do any difference. Alternatively, we can remove the two inductors here, L9850 and L9851, and then see which side of the board the short is. If it's on this side of the board, it tells us that okay, it's on the side of the NAND, and if it's on this side of the board, it tells us that it's on the side of U9850. So let's rather just remove the two inductors instead. Okay, the inductors are out. The next thing we want to do is we want to see what side of our board the short is. Okay, so the inductors are, so I took this out and I took that out, and then this section of the board, let's see, do we have a short on that section of the board? No, we don't. So that is a section of V9850, but on the other side, this side, so this is the equation side, and then on the other side, which is a section of the NAND, that's where we have, okay, what's happening? So we don't have a short on the equation side, okay? Okay, that's a little weird. Let's check that. So we don't have a short here, but we have a short here. It's happening. So pin 2 of L98, 9580 and L9581 is supposed to be the same thing. I mean, they're supposed on the same line. So why do we have a short on pin 2 of... Okay, let's see that. What's happening? Let's just check that again. Okay. Uh, okay. So, okay. So pin 1 of L9581 is actually shorted, and then the pin 2 is not, which is good. So let's check out our U9580. Okay, U9580 is out. Now let's check again. Okay, that's good. That's really good. And then we just hope that nothing has happened to the SSDs yet. So U9580, so you guys can see U9580 is out of the board. So what we did, we had to basically remove the two inductors, and then we measured, and then we wanted to see what side of the board the shorts exist. And we still have the short, but then after we remove U9850, as you guys can see, 9850, after we remove that, the short was gone. So U98, so the short was contained inside U9850. That is good. Yeah, that's really good. Um, and then we just hope that nothing has happened to our NAND. So let us replace that, and yeah, take it from there. So usually when I like as much as I can to use. So we're also taking out C95. Also going to replace C9581 because that also look funny. Although it's not posing an issue to us now, but we hope that might be the case in future. So the best thing we do now is to make sure we address it while we are here. Okay, let's get Arduino board. Okay, so we can use U9080. This is a 2019. This is a 2019 board, 13 inches. So we can. So I can. Let's see if we can grab a U9080 from there. Let's just confirm. It is 0-01-700. Okay, let's do this. Let's go. Uh, so pin 3, 7, 11, 15, 19, 23, not used. U9080. Okay, let's see that chip. 820 dash 01598. Then let's go to. We want to see if we can, if the U9080, U19, U9850. What is it again? Let's go back. U90, U9080. Let's see if it's the same thing here. It says U9080. Yeah, it's the same chip, and that it's TPS 62180. It's the same chip, TPS 62180. Uh, TPS is, yeah, it's the same chip, so we can use yeah, we can take it from here. That is U9080, so we can take that. Even though this is not exactly the same board, so this board, this is an 80-01598. It's a 2019 13 inches, so we can definitely take take it from there. So let's identify the orientation, which is spin one. Spin one is here, reverse. Okay. In one, let's now identify the orientation of our the board that we're working on. Let's see. And then pin one, it's this side. So pretty much it's gonna be like this. Yeah. So it's gonna be like this. Okay. I'm going to replace, I'm just going to pull the caps, the components one time so that I will just, the heat is just going to be once and not, I don't have too much heat in that section of the board. So I will, my components, I will place them one time. So I'm just going to arrange them and then I can place the heat one time. Uh, okay. So now I need something to shield. Um, I need to put something to cover my my NAND, which is U9400, because I don't want to heat it. Okay. Okay, everything seems to fall in place well. Okay. Let's see, we need C9588 still needs to go in place. Uh, mm, mm, mm. Okay, let's take that. Okay, that is in place. Okay, let's take out our coin. Okay, so the next thing we want to, let's see this. Let's see, it's ground. Okay, so the next thing. Now, R5620. So we want to let's see if our let's see if it's still connected to U5620, because I see that the pads seem to be off. So show you guys. See this parts there. So you guys can see that, and this parts there. This and this. They're off. So we want to confirm if we still have continuity on those lines between U5620 and R5620. Mm. Okay, let's see. Okay. Now let's see if we have 2.5 volt on this line. Now, while working in this section of U9580, one has to be really careful that there is no short whatsoever on U98 U9580, because you don't want to send PV bus voltage to your land. That will be really horrible. So let's just be sure we don't have any shorts before we connect power to the board. Okay, let's check for short. Okay, now let's see what we have. Now we can connect our charger. See what we have. Okay, so the board is in the shop. We have trackpad feedback, but we don't have no fan spin. So no fan spin, but we have trackpad feedback, and we can confirm that we have. So a 2.5 volt line is present. We did confirm that, just confirm that again. Yeah, the 2.5 volt line is present. Obviously, our PP bus it's present. So now what we want to do is let us see if our device is in recovery or stuck in DFU mode. Okay, let's see if our device is stuck in recovery. Okay, that's good. Okay, that's not all good, but that it's we see that it's stuck in recovery. The next thing we want to do is let us now put it in DFU mode. Let's put the device in DFU mode. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's try to revive the device. So now we can get the device to put into DFU mode. The first time we couldn't get the device to put into DFU mode because we were having issue with the NAND circuitry. Now we can get the device into DFU mode. I mean, after the replacement of the faulty component, the device was stuck in recovery. We forced the device out of recovery into DFU mode because in recovery in that state we won't really be able to do much. We force it out of recovery to put it to put it in DFU mode. So at DFU mode now we want to revive the option. So here we basically have two options. We have the option to restore, but when we restore, that will erase the contents of the drive. We don't want to do that. We go to the option of revive. So we basically, to do so, we just right click, go to advanced, and then we go to revive device. Let's hope it works fine without, let's hope we don't have any issue. Oh, man. It says installing because I already have the file downloaded. If the file was not downloaded, it was going to download first. And Alhamdulillah, that is an Apple logo. Okay, that is an Apple logo, Alhamdulillah. So that was a successful repair. And I was so scared because I didn't want anything to have happened to the LAN chip. And Alhamdulillah, as you guys can see, that it's a beautiful Apple logo. And yeah, that was a successful one. So yeah, I'm really, really happy on this one because usually when you have a situation like this, like the one we have here, chances are that your SSD might have been corrupted. But Alhamdulillah, in this case, that was not the situation. We see that the revive option, so we're able to place the device in DFU mode, and then here we have Apple logo. We just wait for the process to complete, and then yeah, pretty much this will be a completed successful repair. And then something else. Sometimes the Apple configurator too can be buggy in the sense that you may have the device fully functional, but the device being fully functional, but what will happen is it will still get stuck halfway. So yeah, the device I'm hoping is going to restart now. Yeah, I'm really happy. And, okay, let's see what happens now. So I'll wait for it to complete. Okay, so it seemed to have been completed. Okay, so when you see the lock sign, it tells you that it is the process is successful. So and then that is so now it starts. That starts, and let's hope that it boots fine. It's booting. And so when you see that, that key tells you that you are done, the process is successfully completed, and the device is it's basically booted. And in my case, as you guys can see, the device is booting. I'm not sure if you guys can see that. So let's just wait for it to finish doing its thing. I'm going to see get to desktop. Okay, now I can disconnect my cable. Okay, this is good. We have torch back coming on. It's just trying to increase that. So that is it. Our machine is fully booted. We are on 4% and we are charging 4%. And the device is fully booted. So yeah, I'm really happy about this. And thank you guys. I will see you in the next one. I'm just going to update the ticket and yeah, just update the ticket and that'll be the end of the video. Okay, thank you guys. See you in the next one.